Question number 23. I've got some reagents added to 4 organic compounds. Which row shows the correct observations? Well, let's run down each column first of all. Sodium hydrogen carbonates. Carbonates produce effervescence of carbon dioxide in the presence of acids. So propanoic acid, effervescence. Propanone and propanal are not acids. Propan-1-ol is an alcohol. So this is the only acid. So propan-1-ol is incorrect. So why would propan-1-ol, it's not an acid, produce effervescence? It wouldn't. So I'm going to rule A out. Acidified potassium dichromate. Acidified potassium dichromate reacts with primary alcohols, so it would react with A, but we've ruled A out. It will actually also react with propanal and turn it, an aldehyde, turn it into a carboxylic acid if you heat it, if you reflux it. So that's correct. No visible change, no. I haven't got an alcohol group here. I haven't got an alcohol group in propanoic acid, so all of those are correct. So between B, C and D on Tollens reagent, Tollens tests for aldehydes. So B, silver mirror, is correct. That's an aldehyde. These two are not aldehydes, so why would they produce a silver mirror? They wouldn't. So my answer is B. Which compound is formed by the acid hydrolysis of phenyl methyl ethanoate? We need to first of all work out what phenyl methyl ethanoate is. Well, let's work out what methyl ethanoate is first of all, and then put a phenyl group onto the methyl group. So methyl ethanoate. Ethanoate looks like that. It's an ester, C double bond O. Methyl, you always start labeling an ester from the right hand side. Methyl, and then 2 carbons, eth. And then this C double bond O is an ester ethanoate, methyl eth anoate. Okay, now I've got a phenyl group, and the phenyl group is on the methyl, methyl. So this is my methyl. I've got a phenyl group, which is another word for a benzene ring. So this is phenyl methanoate. Now when it's hydrolyzed, hydrolysis is a reaction with water. It's acid catalyzed. It breaks this ester bond. This ester bond gets broken by water and it forms a carboxylic acid group, COOH, and this O here will form an alcohol. So this part here forms this alcohol. So I'm going to get ethanoic acid, and I'm going to get this compound here. This compound here looks as if it is a C6H5, that's the ring, C6H5, 1, 2, 3, 4, 5, CH2OH. So my answer is A. The student is required to dry a liquid sample of pentanoic acid. Which drying agent is suitable? Well, calcium oxide and calcium sulfate are both good drying agents, so it's either A or B. So which is preferable? Well, if you have an acid, calcium oxide, metal oxides, anything on the left-hand side of the periodic table are metals in group 1 and 2. And so calcium oxide is a basic compound. Any metal oxides are basic, so that's going to react with the pentanoic acid. So I would choose calcium sulfate. That's not basic. It's not going to react with acids. I would choose B. So between A and B, both good drying agents. Calcium oxide, metal oxides are bases. Bases react with acids. Not a good idea. Calcium sulfate is your better choice. Here, the reaction between propanol chloride and benzene is an example of acylation, which is a correct representation of part of the mechanism of this reaction. I've got some horror stories going on here. My answer is C. So what I've got is I've got ethanol chloride, CH3, CH2, CO, and it's had a Cl. I've reacted it with the aluminium trichloride, AlCl3. That's formed AlCl4 minus. I'll have a plus charge here, and this is an example of electrophilic substitution. So this group is going to join on to the ring. It's an electrophile and electron pair acceptor, and it's going to replace an H on the ring. So C is correct. 27. Methylamine reacts with bromoethane by substitution to produce a mixture of products. Which compound is not a possible product for this reaction? So we need to go through the steps. Methylamine is this, methyl with an NH2 amine. With bromoethane, this is CH3CH2Br. The N with a lone pair of electrons bonds onto this C here and releases the Br. So I form CH3CH2N H, it'll lose an H as well when it bonds on CH3, so it forms this. CH3, CH2, Br is replaced, NH2, N bonds onto that C with a lone pair of electrons, the Br is released, and the CH3 is still on the N. It's going to lose an H as well. Then this reacts again, so the lone pair of electrons here will attack this C again, the Br again will be released, so I'll end up with CH3, CH2, N, the H will be lost, CH3, CH2 and a CH3, and then again this N here has got a lone pair of electrons going to attack that C. So I'm going to get another CH2, CH3, I'm going to get 3 of those formed now, and a CH3, and the N, which has just used its lone pair of electrons to bond here, I'll have a plus charge. It's not got an H to get rid of, which could donate its electrons back onto the N and get rid of the plus. So the plus stays, and I've got quaternary ammonium salt. So which one is is not a possible reaction, is D. 2 CH3 groups. I've never got 2 CH3 groups. The answer is D.